Triangle ABC lies in the first quadrant. Points A, B, and C are reflected across the line y equals x to points A prime, B prime, and C prime respectively. Assume that none of the vertices of the triangle lie on the line y equals x. Which of the following statement is not always true? Okay, so I'm just going to go through these one at a time and we'll determine if they're always true or not always true. So, and one thing before I do that, I know that when I reflect a point across the line y equals x, the x and y coordinates are going to change. So first for A. So let's say triangle A prime, B prime, C prime lies in the first quadrant. Well, let's just say I pick the point xy on, that's just going to be some point on triangle ABC. When I reflect that across the line y equals x, that's going to become the coordinate y equals x. Since I know that both x and y are positive, I know that then this coordinate, both coordinates, both the x coordinate and the y coordinate here are going to be positive. Therefore, that point must lie in the first quadrant. So that's always true. B. Triangles ABC and A prime, B prime, C prime have the same area. Well, when I reflect triangle ABC across the line y equals x, I'm not changing it. In fact, those two triangles are going to be congruent. So triangle ABC is congruent to A prime, B prime, C prime. Therefore, they have the same area. I'm not changing the triangle at all. So that's always true. C, the slope of line A prime is -1. So for this, let's just say the coordinate of A is going to be A comma B. Therefore, the coordinates of A prime are going to be B comma A. So the slope of that is going to be equal to A minus B over B minus A. That equals -1, B minus A, B minus A. That equals -1. So that's, again, always going to be true. For D, the slopes of lines A prime and C prime are the same. Well, let's just say if I repeat the same argument with C prime, I find that its slope is equal to -1. Therefore, -1 equals -1. Those slopes are going to be the same. So that is, again, always true. So I'm pretty sure by process of elimination, E is going to be our answer. That's going to be the one that's not always true. But let's just look at it to see why exactly E is not always going to be true. So lines AB and A prime, B prime are perpendicular to each other. So just trying to see why is that not always true. So first, I'm just going to get the slopes of those lines. So A, I'll say is x comma y. B, I'll call A comma B. And then I want to get the coordinates of A prime and B prime. So A prime is going to be y comma x. B prime is going to be B comma A. Okay. So the slope of A prime, B prime is going to be y minus b over x minus a. And one thing, side note here, I know that the opposite reciprocal, for two lines to be perpendicular, the opposite reciprocal of one has to be equal to the other. So for AB, the slope here is going to be, it's x minus a over y minus b. Therefore, just the reciprocal is going to be equal to y minus b over x minus a. So I can already tell this isn't going to work out. So for two lines to be perpendicular, it's got to be true that -1 times the opposite reciprocal, so -1 times the reciprocal, -1 times y minus b over x minus a, that's got to be equal to y minus b over x minus a. Well, if I do this, so -1 equals y minus b over x minus a, and this is then going to become times x minus a over y minus b. So we get that -1 equals 1. That's a contradiction. So we know that that is not always going to be true. So that is why E is our answer. The slope of A prime B prime does not equal the opposite reciprocal of the slope of AB. So the answer is going to be E.